going to discuss about inertia. Inertia is nothing but resistance offered by an object. Means it resists the change in state. It opposes the change in state. Like so, when the object is on the table, like by example, you want to drag the table, right? You want to drag the table from that point to somewhere. So when you want to drag the table, you need to apply force more than weight of the object, or the force is required to displace the object. Certain amount of force is required to displace the object. So until that time, the object is trying to stay in the same state. It's not only more than weight of the object. Certain time it's required the certain limit of force. Certain minimum force is required to push the object or pull the object. Right. Okay. So here you can observe the inertia is nothing but, so it opposes the change in state. Opposes the change in state. So there are three types of inertia: inertia of rest, inertia of motion, inertia of direction. There are three types of inertia. Inertia of rest I'll discuss. Best example, carom board. So you can arrange the caroms in a vertical position one by one. So on the top, one by one on the top. So if you hit the carom, if they hit carom, the bottom coin will displace, remaining coins will move in the same place. And one more example. So you shake the branches of the tree, the fruits will fall down, but the fruits will fall down when the branches of the tree comes under motion. Here the inertia of rest is, which part is there in inertia of rest? Fruits. And one more example, I'll take one duster. Okay, you dust it. Okay, the particles on the duster will come down. Okay, the particles on the duster will come down. The duster will move. The duster will displace, but the particles on the duster will fall down. So here, because of inertia of the rest, because inertia of the rest, the particles will come down. The duster will move. That is one example. And one more example, so you can take a carpet. You take a stick and dust it. Carpet, so big carpet is there, dust particles will be there. You take a stick, so hit the carpet. What happens? The carpet will move, but the dust particles will remain in the same position. That's why the dust particles will fall down. That's one example. And one more example, so we are spreading the cloths. Okay, so we are like this, we are doing like this, right, before spreading on the wire. When you do like this, cloths, wet cloths, the water droplets will stay in the same place. The cloth will move, the water particles will stay, the cloth will move. That's why the particles, water droplets will fall down, because of inertia of rest. And one more example, so we are in the bus. Okay, moving bus. Suppose you take we are in the moving bus. Okay, so suddenly the bus driver apply brakes. What happens? In which direction will fall backward or forward? Suddenly, so what happens? Will fall forward, because our lower part will be attached to the ground, our upper part is still continuous in the motion. That's why, because of inertia motion means our upper body still is in the motion, but lower part it will be attached to the ground, it will stop immediately. But our upper part, so our body will be continuous in the motion, that's why still it will move. Inertia of rest, lower part will be inertia of rest, that's why so will fall forward. So one more example. So the same bus is at rest. We are sitting. Okay. Suddenly the bus starts. What happens? Our lower part, so our upper part will be at rest. Our lower part will be moving along the bus. So because of inertia of rest of upper body will fall back. That is the reason. So I hope you got it. So inertia of rest. So many examples you got it. And one more thing. Inertia motion, will go to the inertia motion. Fan, you see. Fan. Okay. So when it is on, it continuously moves. When you off the fan, what happens? It immediately it won't come to the rest. Will it come? Did you observe any time when the fan is on, so on position, when if you off the fan, so speed won't decreases suddenly to 0, slowly it will decreases, right? Why? Because inertia motion, still the motion continues. So a long jump person, the person is taking long jump, high jump, so they'll move little bit back to get inertia motion, because by running they'll get inertia motion, so they will move forward, little more forward. So inertia depends on mass. If more mass, more inertia, less mass, less inertia, right? Heavy vehicles have more mass, so more inertia, lighter vehicles. So that time we can able to observe that one. And one more example, inertia of direction. So what happens when we are moving in a particular direction, immediately we want to take turn, so we will move in that particular direction itself. So best example, when you are getting down from the bus, so slowly running bus, what happens? We have to move in the same direction until certain distance. Then only we will stop, otherwise we won't stop. Right? Immediately we won't come to the rest, right? So we have to move in the same direction. And one more example, we can say particles. So during rainy time, you can observe the cycle wheel. So the water droplets will move along the tangential direction. So and one more example, I will tell very important, very effective example. You take a stone. So I hope you know the stone. Stone you take. Okay. Take a thread. Tie the stone to the thread and whirl like this. If you whirl, what happens? If you leave, it moves along the tangential direction. Yes or no? Along the tangential direction, it will move. Take a stone, take a thread, so tie it and whirl like this. If you leave, it moves along the tangential direction, along the particular direction. So that we can say inertia of direction. So these are all examples, inertia of direction. So I hope you got it about inertia. So today inertia is nothing but resistance, opposition to the change in its state. That is inertia. How many types are there? 3 types. What are those? Inertia of rest, inertia of motion, inertia of direction. There are 3 types. So I hope you got it. So this is about complete and brief idea about inertia. If you like this video, please do like. So at least I'll feel yes, somewhat the content is reached to the students. So I'll feel. So if you like the content, please do like and share and subscribe. If you more like the content, please do subscribe my channel. So this is our Siva sir. So we'll continuously will be in touch. Thank you so much. Signing off.